496.22 kilometers per hour. This figure does not belong to a Bugatti, a Koenigsegg, or a Rimac. It belongs to a vehicle produced in Shenzhen, China. On September 20th, 2025, BYD's luxury division, YangWang, unveiled the U9X. While official pricing is pending, industry insiders suggest a staggering figure, 10 million yuan. That is nearly 1.4 million US dollars. Let that sink in. This is not a budget alternative. This is a declaration of absolute supremacy. BYD is telling the world, we don't just want to beat Ferrari on the stopwatch. We want to challenge their status on the auction block. Today, we are ignoring the marketing hype to answer one single question. Does the engineering inside this machine, from the 30,000 RPM motors to the 30C discharge battery, actually justify a seven-figure price tag? To understand the U9X, we must first address the battery paradox. Traditionally, hypercars rely on nickel-cobalt-manganese (NCM) chemistries for their high energy density. Lithium iron phosphate (LFP) was considered the safe but slow option for taxis and buses. BYD has inverted this logic. The U9X utilizes an 80 kilowatt-hour LFP blade battery pack capable of a continuous discharge rate of 30C. 30C is a violent number. It means the battery can theoretically discharge its entire capacity in just 2 minutes without thermal runaway. This allows the pack to deliver over 1,000 kilowatts of power instantly, essential for accelerating a 2.5-ton vehicle to 100 kilometers per hour in 2.36 seconds. Achieving this with LFP required a fundamental redesign of the thermal architecture. When you pull 3,000 amps of current, internal resistance generates immense heat. BYD implemented a dual-layer direct cooling system, sandwiching the cells between active cooling plates. This increases the heat dissipation area by 100% compared to standard EVs. Furthermore, they optimize the cell structure to minimize internal resistance. This is not just about raw power. It is about repeatability. The U9X can sustain peak power output even as the state of charge drops to 20%, a critical capability for track performance that many electric competitors fail to deliver. The heart of the U9X is the E4 powertrain system. It consists of 4 independent motors, each rated at 555 kilowatts. But the headline figure is the speed, 30,000 revolutions per minute. Spinning a rotor at 30,000 RPM creates centrifugal forces that would disintegrate standard copper windings. To prevent the motor from tearing itself apart, BYD utilized a 970 megapascal high-strength rotor, wrapped in aerospace-grade carbon fiber. This allows for a compact motor density that delivers over 750 horsepower per wheel. Supporting these motors is the world's first mass-produced 1200-volt silicon carbide platform. Why 1200 volts? Efficiency and thermal management. For a given power output, higher voltage allows for lower current. Lower current means less heat generation in the cables and inverters. Specifically, a 67% reduction in thermal loss compared to an 800-volt system. This allows the U9X to use thinner wiring harnesses, reducing weight, while maintaining continuous high power output without overheating the power electronics. This is a clear example of how voltage architecture dictates performance limits. Power is nothing without control. This brings us to the DiSus-X intelligent body control system. Unlike traditional active suspension systems that use air springs or magnetic dampers, DiSus-X utilizes a high-voltage hydraulic system capable of instantaneous force adjustment. The system has a response time of 40 milliseconds and can generate over 1 ton of lift force per wheel. This allows for active anti-roll and anti-pitch control that eliminates the need for traditional mechanical stabilizer bars. The most visceral demonstration of this is the vehicle's ability to drive on 3 wheels, compensating for a tire blowout in real time, or to perform a stationary vertical jump. While these may look like parlor tricks, they demonstrate a level of control authority that allows the computer to dictate the vehicle's physical attitude under extreme cornering loads. The architecture we are seeing in the U9X, specifically the integration of the DiSus active suspension with the E4 drive system, is not just for hypercars. It is the precursor to BYD's mass market strategy. The algorithms governing this zero-roll, zero-pitch behavior are being trickled down to the Denza and Fangcheng-Bao lineups. For automotive engineers and product strategists who need to understand the specific control logic, hardware integration, and sensor topology of this system, we have published a comprehensive technical study, BYD, DiSus-Z, and Integrated Architecture. This report goes beyond the press release specs. It analyzes the control unit architecture, the hydraulic schematics, and the supply chain partners enabling this technology. If you are benchmarking the future of chassis control, this document provides the engineering granularity you need. The link is available in the description. The chassis of the U9X is the largest mass-produced carbon fiber monocoque in the world. It uses T700 grade aerospace carbon fiber, achieving a torsional rigidity of over 54,000 Newton-meters per degree. Historically, producing a carbon tub of this size required labor-intensive handling processes, limiting production to a few hundred units a year. BYD, however, has industrialized this process. They utilize a novel bonding technology and automated high-pressure molding to reduce cycle times. The cockpit alone accounts for 30% of the vehicle's weight reduction strategy. By bringing carbon fiber manufacturing in-house, BYD ensures that the structural integrity required for 3,000 horsepower is consistently met across a production run, rather than just a prototype. In February 2025, YangWang demonstrated a capability that fundamentally changes the definition of a driver's car: autonomous track driving. Using the Eye of the Gods ADAS system, the U9X can navigate a race circuit at limit handling speeds without a driver. This is not just lane keeping. This is real-time friction circle optimization. The system uses high-frequency sensor data to calculate the optimal braking point and turn-in angle with millimetric precision. For the owner, this translates into a digital racing coach, an onboard AI that can analyze your driving line and teach you how to extract the maximum performance from the vehicle. It merges the digital and mechanical realms in a way that Ferrari or Lamborghini have yet to attempt. If the rumored price of $1.4 million is true, the U9X enters a rarefied atmosphere. It is no longer competing with the Porsche Taycan or Tesla Plaid. It is hunting the Rimac Nevera and the Bugatti Chiron. At this altitude, the value proposition changes. It is not about transportation. It is about art and engineering dominance. Even at $1.4 million, the U9X is significantly less expensive than the $2 million Rimac Nevera. Yet it offers higher top speeds and a more sophisticated active suspension system. BYD is effectively saying, we can deliver $3 million performance for half the price. This is not an economy car strategy. It is a disruptive luxury strategy. It challenges the very idea that heritage is the only metric for value in the hypercar world. Make no mistake, the 10 million yuan price tag is a psychological threshold. For decades, made in China meant affordable. With the U9X, BYD is shattering that glass ceiling forever. They are demanding the same respect and the same valuation as the century-old houses of Maranello and Molsheim. History teaches us that brand prestige follows engineering breakthroughs. By pricing the U9X in the stratosphere, BYD is betting that the global elite will pay for the absolute cutting edge of physics, regardless of the badge on the hood. The hierarchy of the hypercar world has been static for a century. It is static no longer. We are witnessing the rise of a new center of gravity. To track how this gamble plays out and what it means for the future of the automotive industry, stay with us. Subscribe to master the world's fastest moving tech market before your competitors do.